All right. What should we start with on going through this? I'm not sure we'll be able to go through all of these things. But yeah, I want to do as many as we can. But if there's a place you'd like to start. So you want to look at 19 and 20 from 439? Okay. That makes sense because the handout has the answers attached at the end, right? So that makes sense. Yes. No. Yes. Yes. All right. So for 19, we notice that if we try to draw a picture of this, well, we know that the side opposite that angle.
Well, yeah, but I'm saying like the A, B, and C. Should you put them in should A always be on the bottom left and C on the right?
It doesn't really matter. I was just about ready to write not to scale afterwards because I don't really know if this is an acute triangle or obtuse or any of that. Like I can't tell from the information that's given to me. Is everybody okay with that much? Okay. So I can see that this is an SSA situation.
If she's asking if you're going to tell us LOC used.
No. Yes. I will give you the formulas for the law of sines and law of cosines. So you have the formulas, but I'm not going to tell you which condition you use which formula at, but it should be obvious because you can't do a law of sines when you have to do the law of cosines. You don't have enough information, so it should be like if you tried to plug it in, you'd be like, there's two things left that I don't know. I can't do this. So we'll do an example where you have to solve for an angle in the law of cosines here in a minute. Because that's what that is. That's just solving for an angle from the law of cosines. It's a side-side-side solving problem, is all that is. It's just you're looking at like an intermediate step inside of a side-side-side law of cosine situation. So let's finish this one and we can go back and circle around to that, something like that, okay? Okay. So the law or the SSA situation is one where we have to be careful. The place where we have to be careful is if the angle that we're given is acute. Is that what's going on in our case? And then also if the side opposite the given angle is less than the other given side. Oops, I forgot to write side there. Is that what's going on here? Yes, because 16 is less than 17. So that means for us we have two triangles possible. Is everybody so far so good? Any other situation, you will not have two triangles. You could have 1 or 0. You could have like the impossible situation. I think we saw a homework problem where that happened. We did an example in class where that happened. That's what it was, right? So that could also happen in the SSA if you get like some cockamamie error. That's what that's saying. Yes.
So those 2 bullet points are how you know.
It has to satisfy both of those 2 bullet points, and that will indicate to you that the SSA is going to give you 2 triangles.
And if the side opposite is given angle, the other is given.
Sorry. This I should probably write angle less than the other given side. So the side opposite the given angle has to be less than the other side that's given. Right, like we saw here where 16 was less than 17. Okay with that? It's just hard to kind of write that in words, right? It's just awkward sounding. Okay, so let's use our law of sines here. So I'm going to say sine 64 over 16 is equal to sine of b over 17. Everybody okay with how I plug that in? Yes, Gabby?
So, the side opposite of the given angle is the other given side?
Less than has to be less than. Yeah. Should I write less than? Less than. Sorry, I was using an inequality there. No worries. So to solve this, we'll cross multiply. So that gives me 16 sine b equals 17 sine 64. And then we'll divide both sides by the 16. And then to get the b by itself, how am I going to get rid of that sine wrapped around it? That's the sine inverse. So I'm going to type this all into my calculator in just one big swoop. It's also reasonable that you would type this in steps, but you can do it all in one step. And that's the way I prefer to do it, just that there's less rounding involved. Doing it that way. So when I type that in, I get 72.7 approximately. So I'm going to make a triangle 1 column. And then I'm going to have a triangle 2 column. So over here I know A is 64, little a is 16, B is 17. We know that same thing for triangle 2. For triangle 1, we know angle B is 72.7 degrees. For triangle 2, our one answer for sine inverse is 72.7, but sine is also positive off in this quadrant. Yes, Bella? So, to get rid of this sine that's wrapped around the b, what I have to do is sine inverse to both sides. That cancels the sine off to get the b by itself. So anytime you have to solve for a variable that's inside of a sine or cosine, you'll have to use an inverse at some point in the problem. Is that satisfied? Okay. So does this look familiar, what we're doing here? We did this on the last test, right? On the solving test, right? When we tried to find the other solution inside of 360, we did this exact same process. So the 72.7 is here and there. So the leftover part, let's draw it in a different color. This piece, that's the angle that we want. You're talking this? Oh, yes. Yeah, sure. No, 72.7 isn't part of the second triangle at all. It's part of the first triangle. Yes. So angle B in the second triangle then is going to be 180 minus that. So that's 107.3. Mm-hmm. So let's re-explain what we're doing here. Let's re-explain what I'm doing here. What I'm doing is I'm going back to this thing right here. So if I solve this, I know you do, but I don't think everyone else does. So that's why I'm going to go back and re-explain here from the beginning. Okay, and I'll circle back to what you're asking about. I promise. It's become clear after, like this many questions that people don't understand why I'm doing this second thing. So when I take I take 17 sine 64 divided by 16. When I type that into my calculator, I get like 0.95 and change. Now if I solve this by taking the sine inverse of both sides, and I ignore that this is a part of a triangle, if I just think about this as a solving problem, when I type that into my calculator, I get that 72.7. There's that answer. But I know that when we solve sine, that's positive in the first and second quadrants. So there, because we have sine is positive 0.955. So we have a second solution floating around here. It's that. Now I don't have to worry about where sine in the third and fourth quadrant is, because sine would be negative in those quadrants, and that's, my sine is positive, and it'll always be positive. Furthermore, if I was trying to solve for an angle and my answer was in one of those two quadrants, it would imply to me that my triangle had more than 180 degrees, because all of the angles in quadrants 3 and 4 have more than 180 degrees. Does that make a little bit more sense why that second solution is coming in there? In your previous situations, when we do this, the other options here, like if the given angle was obtuse, you can't get an angle in the second quadrant because that angle is bigger than 90, and two angles that are bigger than 90 are bigger than 180. So that's nonsense, right? And if your opposite side is bigger than the other given side, you're going to get an obtuse angle when you do the inverse, and then the same kind of thing happens. Like you end up with something that's too big in that second triangle if you try to do that. Okay, so Julia, you were going to ask something here? So I haven't drawn a picture of the second triangle yet. Oh, yours, I guess it would be like that. Yeah, so it'd be something like that. You're getting an obtuse triangle out of that. The stuff in the middle. Yeah. Yes. Okay. So we now have angles A and B in both triangles. We can solve for C in both triangles now. Is the answer for C going to be the same? No, it should be different in each of them. So to find C, I can do 180 minus 64 minus 72.7. And here I can do 180 minus 64 minus 107.3. So this one I get 43.3. And this one I get 8.7. So those are my answers for angles B and C. And you should probably make sure that you're writing like degree symbols on these because it's really easy to confuse like 8.7 with a side length, right? So you be careful about that. Everybody good so far? You may. Okay, we have one thing left to find. That's side C. To find side C, we could use either the law of sines or the law of cosines. So we have enough information to do both. Anyone with a preference? Law of cosines. Okay. So that tells me C squared is equal to A squared plus B squared minus 2AB cosine C. So that's 16 squared plus 17 squared minus 2 times 16 times 17 times cosine of 43.3. So I'll just type that into my calculator. When I do that, I get 149.1-ish. Mr. Kulik, that's got to be wrong. That seems way too big to be a side length. What am I forgetting? It's C squared. Oh! So what do we need to do to that? Yeah, we just need to square root it. And when I do that, I get a much more reasonable 12.2-ish. Ah! That feels much better. If I'm going to use the same method to find C in the other triangle, what's the only thing I need to change in my law of cosines formula? What's angle C? 8.7, right? So it's going to be exactly the same stuff. So that gives me 7.26, and when I square root both sides, I get 2.7-ish. Usually after the first step, you can do either one. So after you're usually required, based on what you're given, to use one or the other. You only have enough information to do one of them. After that first step, though, you usually have enough information to do either one. And at that point, it doesn't matter. Either one is fine. Okay? All right, which one do you want to look at next? .38. Which 38? I think I signed 38 from two different pages like a dummy. The first 38 or the second 38? Uh-huh. Sure. So this is from 449, number 38. So it says, Tony must find the distance from A to B on opposite sides of a lake. He locates a point C that is 860 feet from A and 175 feet from B. He measures the angle of C to be 78. Find the distance of AB. So you're going to get to see some stellar looking artwork from this guy. So we have some kind of lake here. So we know that this is 860 feet, and we know this is 175 feet, and we know that this is 78. So you're given a picture like this, and it wants us to find this side AB. So if I look at my situation, this is a side angle side situation. So I should use which one? Law of cosines. So I can just say x squared equals, I know you can, I'm just going to do it for everybody else though. 160 squared plus 175 squared, 2 times 860 times 175 times cosine 78. So 860 squared plus 175 squared minus 2 times 860 times 175 times cosine of 78. And that gives me a big old whopping number. I'm not even going to write it down. I'm just going to go straight to square rooting. And that gives me 841.2 feet. Okay with that, yous guys? Yous guys? Why am I not solving for any more of the triangle? Doesn't ask me to. Like, could I? Oh yeah, sure. Do I got all that kinds of extra time to burn, wasting my time doing things I wasn't asked to do? Yeah, I'll pass. Yeah, Bella. The law of sines and law of cosines will be provided to you on the test. Correct. Kelly? You will have a story problem on the test.
Will you give us a picture? Are you going to give us a picture?
I did provide a picture. Yes. At most one. So the criteria was here. So it has to be a side-side situation, or side-side angle situation. And then the angle that you're given has to be acute. And then the side opposite the given angle has to be less than the other given side. I think they were, if I scroll up, they were these two, 19 and 20, right? Sure. Is that what we want to do next? Yeah, I think that we assigned one of them from the sheet that was a side, right? Does anybody have the sheet, the practice sheet in front of them to check for me? Tommy, do you have it there? $16, okay. Okay. And so we have some kind of triangle. I assume it kind of looks whatever. Can you tell me the side lengths for it? Okay, 28.7. Okay. Okay. Thank you very much. Okay. And let's say that let's pick an angle to solve for. We're asked, I think, to solve this triangle, correct? So let's just say that we're going to solve for A first. Everybody okay with that? Okay. So the formula for the law of cosines that I want then is this one. Everybody good there? Why did I pick that one? It's the only one with angle A in it. So I can fill things into my formula now. B is 17.7 squared minus 2 times 28.7, 17.7 cosine A. Woo! Almost ran out of space there. That says cosine A. I guess I could have just scrolled over. We don't need. We have some space at the edge there. Okay. So my goal then is to get this part by itself. Everybody good with that? So I'm going to start by subtracting these two things to the other side. Everybody good with that? When I do that, 25.6 squared minus 28.7 squared minus 17.7 squared is going to be negative 481.62 equals, and then I guess I might as well multiply this stuff together to get the coefficient. So negative 2 times 28.7 times 17.7. That gives me negative 101.5.98 cosine A. Is everybody okay with that? Now, this is the confusing part is for students that I see make mistakes, is that they'll take the coefficient on that cosine of A and just add it into the other things, or they'll add it over to the other side. Keep in mind that this is this piece, everything that's going on, this is all multiplication. Right? Everything that's going on there, all those numbers are being multiplied together. They're not being added and subtracted. You have to divide it to the other side. So that's my next step. Is everybody okay with that? So when I do that, I get 41.62 over 101.598 equals cosine of A. Where did my negative signs go? They canceled, right? I had a negative on top and a negative on bottom. If you had started by solving for angle B first, you'd end up with the same answers, regardless of which ones you started with. So you might be off a couple of tenths in the decimal place because of rounding stuff, but ostensibly you're going to get the same answer. Okay. So my last step then to get angle A is to do Bella? How am I going to get rid of the cosine? Yeah, do cosine inverse to both sides. I was picking on you because you asked about it earlier. So I go to my calculator then. Cosine inverse of 41.62 divided by 101.598 gives me 61.7. So So there's my angle A. Now to find angle B, what can I do? I could use law of sines now. I have enough information to do that. That seems like less work to get the angle out of than this does. Would you agree? That seemed like a lot of algebra to get that angle to spit out. So if I'm going to use law of sines, I'm going to have a side ooh, that's got to be careful here. Oh, that's okay. So I have a so I'll use that. So I can say, oh, not that one. That one. Or not that one. There we go. So I can say sine of my newly found angle A over 25.6 equals sine of angle B. What am I having to worry about here? Two triangles. How can we avoid that? Or I can do that, where now my opposite, the given angle is bigger, or the other given side is bigger, so I can avoid having to do that. Or you could use law of cosines, as Megan suggested. Either one is fine. I just noticed that I was running into a possible two triangle situation that I would prefer not to go down that route. You'd find, though, that the second triangle would give you some nonsense thing. But I didn't want to, I don't want to go near that. Everybody okay? Angle side. Yes. You could do side angle side, but that's a law of cosines. But yeah, it would be easy to do, but it'd be just like the one we just did algebraically. So I was like, that seemed like a lot. This is usually a little bit less in terms of like crapola to move around. So divide the 25.6 over. And then to get rid of the sine in front of the C, Bella, what do I use? Yeah. And I'll just type that stuff into my calculator. I don't know. To me, that seemed like a little less stuff to do. I mean, you could do law of cosines again, like no big deal. The inverse formulas.
It's like, so you don't have to go through all of the algebra stuff, like cosine A equals negative A squared plus B squared plus C squared over 2BC. Or you just plug that in and then have this for cosine A, B, and C.
Well, I mean, if you have this formula.
It's like just subtracting stuff on it.
Mm-hmm.
But can you show that? Because I was confused on how
So we just subtract the b squared over, and then subtract the c squared over. That gives me this, right?
So then we divide it by negative 2bc.
Mm-hmm.
The negative crosses out, and that's why there's a positive.
Right, and then they just mess around with the negative signs. So if they push that negative up into the numerator, the c is now positive, the b is now positive, and the a is now negative. But I mean, there's no reason that you can't just leave the negative sign in the denominator. Like, it's not wrong to do that.
The same way?
Yep.
Okay.
Yeah. So I mean, it's like I gave it to you already. It's just a rearrangement of something that I gave. Yeah. So like. And now I can find angle B. How can I do that? Yeah, I just subtract from 180. Don't let me catch you trying to do the law of sines or cosines again when you can just subtract. Right? Like, that's one of those, like, oh, you just wasted a whole bunch of your time. What else? We have enough time to probably do one more one that's not super long. Sure. I mean, it's certainly possible. That can't happen on side. That ought to exist. So try that. Oh, let's put some labels on this. That way when people find angles, we can be like, oh, I got angle A to be this, not angle B to, and it's like, oh, it's because I didn't label anything. So. Yeah. The 10th is fine. Well, my answer to that, Megan asked, how would you know if it's possible to have two triangles if all you're given is the side? You can't have two triangles from this, but you could end up stumbling into like an SSA scenario where you would want to find a second triangle. That second triangle end up not working. What you can do to guarantee that you never run into that is if you find the biggest angle first. So if you start by finding the angle opposite the biggest side, you'll never be in an SSA situation when solving one of these things. I'll point out to you that it's SSA. Doesn't mean it's a double. So you do need to know that criteria that we pointed out at the beginning there.
So, just like about this, so law of cosines, is that just used to find angles, or law of sines to find sides?
You can find either one with each of them. So like in an SAS situation, you can use the law of cosines to find a side. Or in a what is it? It's a angle side. You can find, or no, the law in an SSA situation, you can use the law of sines to find the